Hello, welcome to my show and Happy New Year. This is my first show of 2021, so it's as if I've totally forgot how to do a live stream. Minutes late starting, delayed on the intro, scrambling last minute to get some more information about today's topic. I'm super excited. Um, we're going to jump in here in a minute. I am by myself today, so no guests today. We got guests scheduled later this month, and I'm excited to talk about that. But yeah, we're going to talk about ARM. Because people in the Apple ecosystem have been talking about it for a few months just because of the new Apple laptops, but it's a constant looming problem, opportunity for every developer, and it's not just about Macs. It's actually going to be about everyone. It's going to be about servers. It's going to be about Windows. It could eventually be something that affects mobile development, which is already really there because we're already doing ARM on a lot of mobile devices. But there's a lot to think about. I only thought of this show this morning because in the middle of the night last night, I basically was it was coming to me the realization of where this is going to all go. Once Apple decides everybody's going to be on an ARM processor and you can't buy an Intel Mac anymore, and there's so many developers on Mac, we're essentially going to get to a point where this is now an arms race of Apple's processors are amazing now. They're cool. Their battery life is great. Their performance is amazing. Like everyone's going to love it, supposedly. I'm waiting for my M1. My Mac is a couple weeks out. But there's a lot to unpack here because this affects developers. And Docker has been doing this stuff for years. Docker has been making this cross-platform, cross-architecture development easier for years. And there's lots of, I wouldn't say hidden, but there's lots of features about Docker that people don't realize are already there for doing this kind of cross-platform architecture development. Today, you can do this now. You actually can develop for ARM without the M1 Mac. You can actually develop for Intel for x86 64 architecture on an M1. We can do all that now with Docker. So I wanted to go into demos. I want to get into your questions. I'm going to constantly stop to look at your questions and talk about this because this is bigger in my mind. This eventually will lead to us all possibly have not only having to build our applications for ARM and Intel, or maybe in some cases just ARM, but we're going to have to develop that way. And we're going to have to consider our development teams on different architectures. How do we all work together? How do we develop together? If some of us are on ARM and some of us are on Intel, like how does that all even work? Well, luckily Docker has already got the solution. It actually is already there. It just may not be obvious to you. So I want to dive in. I will say that because I don't have an M1, I can't give actual M1 demos, but I have some great videos. If you actually search on YouTube, there's already a couple of great demos and examples, and I will point those out as we go. And if you're watching this after the fact, they will be in the description below so that you can see what we're going to talk about today. All right, let's talk about questions. I really want to know what you don't know yet. Like, what are you concerned about? Do you have any concerns? Do you already know all this stuff and you're just here to hang out? Or is the M1, like, to me, the M1 was very confusing because at first when they announced it 6 months ago, I was like, okay, how does this even going to affect me? They said Parallels and Docker will work, but to the Docker team's surprise, they didn't really know much at the time. They didn't have a demo machine yet. They didn't know how to play with it. So, it was kind of an announcement in the dark that Apple was keeping such a secret lid on it that, even the people that were going to eventually make this all work didn't know how it was going to work yet. So let's talk about it. Get to your question. Hello, everyone. So the difference Docker on ARM and x86. Yeah, so we're going to start out with the basics, and then we're going to get into the complicated demos. Not necessarily complicated, but we're going to talk about things like manifests and architectures in Docker and how, what image are you actually running? What architecture are you running when you type Docker run, on different systems? If I type Docker run on a Raspberry Pi, and then I type Docker run of that same command on a Windows machine or a Mac, what's happening in the background? That's all really great stuff. And I don't talk a lot about it in my courses. I do touch on it on my Docker for Node.js course because Node is one of those images that happens to work on ARM and x86. So I talk about cross platform development. If you remember, almost 2 years ago, about a year and a half ago, Docker made an announcement about a partnership with Arm and how they were going to make Docker the best place to do Arm development. Because at the time, 99% of all developers were all on Intel machines. So if we wanted to develop for an Arm, we either had to go jump into SSH on a Raspberry Pi, or we had to use Docker Desktop, which already comes with an emulator. We'll talk about that. That's called QEMU. We'll talk about what that is and how that works in Docker Desktop, how you can use it, how you can use it on a server. You can actually set it up on your servers because it's not there by default. Yeah, lots of stuff. Security of Docker. So today I want to focus on this Arm stuff, this architecture support, multi-architecture specifically, not even just Arm, but multi-architecture in Docker. And I'm not going to focus too much on security. So thanks for the question, but come back next week. Maybe next week we can answer the question on the security of Docker, because that's actually a great topic. If you look back in my Bret.live channel, if you kind of search for security in that channel, you will find past episodes where we talk all about security. I have security experts on. Actually, last year we had a number of shows where we talked about security. Happy New Year to you. Hello, hello. Happy New Year to everyone. All right. Thanks for being here. All right. Right into it. Nice, Pickle Rick. Right into it. Do you foresee anyone outside of Apple making a competitive to M1 ARM chip I can run Linux on? Emphasis on competitive. I think they have to. So this is the thing I was thinking about last night. Like, when there's billions to be made in any market, there may be a dominant player, but eventually there's going to be legitimate competition. So Apple has been buying up chip manufacturers and reserving space with chip manufacturers for years on all of their A processors, right? And now we're calling this one M1, but I think it's effectively an A14 chipset. It's a 64-bit ARM architecture. So we've got, and they're not the only ones making ARM, right? Like AWS now makes their own ARM chip in their ARM servers, and they're not necessarily, I'm not sure the competitive analysis of the performance spec on them. Like if you got an M1 Mac and then you've got the top of the line ARM machine on AWS and you did sort of a CPU or IO well, I wouldn't do IO because that's obviously probably going to be better in a laptop than it is on a server, but who knows? The server would have to have like local SSD on. I don't know if AWS's servers have how their SSDs are attached, on their storage and stuff like that. So we've got servers already that can run ARM. We've got laptops that can run ARM. Windows has an ARM version. It's not great, but here's my thought: is if Apple's going to start putting out these crazy laptops, and what I mean by crazy is there's a great video that kind of spawned. I think I watched this yesterday, and I had to let it sink in. There's a lot of stuff coming out right now about M1 and what that means for the average user. There are some great videos starting to come out about developers on M1 talking about Visual Studio Code, and there's actually been some bugs in a lot of this stuff. Go has bugs. Apple actually has bugs. And VS Code, the underlying architecture of VS Code, has been buggy as well. I use multiple apps that rely on the JavaScript underpinnings of VS Code, and those have had some quirks over the last couple of months with this as well. So, as well as Big Sur. So if you're on Apple, like you've got multiple problems right now. We've got a new OS and we've got a new architecture, and both have problems. So the hypervisor framework is new in Big Sur, or at least updated. I'm not sure if it's brand new, but it's an updated version of the virtualization architecture that's also got some challenges in terms of changing over. But anyway, this particular video, I will put the link into chat. As you can tell, I'm excited about this stuff. This is pretty cool. So this video talks about how, even Linus Tech, like all these videos that are showing the performance differences of Apple show that it's clearly kicking butt for a small amount of money, right? Less than $1,000. You can get a laptop that's outperforming just about everything else out there, especially when it comes to battery life, heat, fan noise, all those things. I got jet fans running in my Apple MacBook right now. That just happens when I turn on a camera and screen share, essentially. That's all I have to do to make it sound like a jet. So they did all this performance testing, and like the M1 MacBook Pro lasted, I think, 8 hours compared to the best Dell or HP or something. So right now what we've got is a disparity in the market, and anytime there's a vacuum like that, there's going to be competition that's going to try to take advantage of that vacuum. So on the Windows side, Dell, HP, all these companies, um, they have got to step up, right? So they're probably scrambling, pissed off about this Apple announcement, because they talk about in this video that people are already switching. I mean, of course, people switch every day from Mac to Windows and Windows to Mac. Like that happens for various reasons, but it's starting to happen right now in ways that is going to be problems later on for HP and Dell if they don't step up. If these PC manufacturers don't step up and start delivering better battery life, and they may not be able to do that on Intel. Like there just may not be an option anymore, and they are going to be forced on the ARM. So I see this coming out of like, if we can't get Intel chips that can actually compete on a energy, what is it, CPU power per watt thing that they do, the calculation. Somebody in the chat, please help me out on that. Performance per watt, whatever that is. Like if there's not an Intel solution to that, performance per watt, because that even matters in the data center as well, right? So your servers are going to be cheaper in AWS if you can get better performance per watt. So if we can't fix that on the Intel side, then there's going to be this shift to ARM. It just has to be, because everyone will start moving to Apple computers because they last so much longer and they're so much faster and they're so much cheaper for performance per watt. It's just inevitable. And of course, these companies aren't going to let them do that. There's billions of dollars on the line. So in my mind last night, I was like, okay, this is going to lead us down a road where either it doesn't look like there's an Intel architecture that's going to miraculously fix all these problems and cause it to be truly competitive with Apple's M1 ARM. And Apple's creating their own silicon. So they have a competitive advantage because they've been buying up these companies and buying up chip manufacturers and reserving space with chip manufacturers so that no one else can use them. So there's other companies out there that are going to have to start doing this. And, I can just only imagine in the boardrooms of HP and Dell and all these other laptop manufacturers on the Windows side and Microsoft themselves, because they make the Surfaces, like they're beating their fists saying, we've got to be able to compete. Like they're looking out years, seeing that, okay, we already got this M1X that they're talking about, and it's probably going to be an M2 eventually. Like if Intel's not going to be able to close the gap on performance per watt, then people are just going to switch. And people are going to figure out that maybe running Windows on a Mac is actually faster than running Windows on a Windows machine. Now, this has kind of happened a little bit before. It happened, way back like a decade ago, because the way I got into Mac was when the MacBook Air came out, the original one. It was the thinnest, lightest, sleekest laptop to run Windows. It was better than like the Lenovo's that I had. It was better than all of them. And so I was actually a convert because I wanted to run Windows, and I wanted it on a simple, sleek little laptop, and I bought a MacBook Air for that. And then I've stuck with it ever since. Ever since then, I've been on Mac. Not because I hated Windows. It's just it slowly converted me over time, right? Because of various efficiencies with Apple. But I still love Windows. I still use Windows almost every day. I've got a Windows server sitting in the closet. Like I'm still a Windows fanboy. I love Surfaces. If I had a use for one, I would own one. I actually just sold my old Surface because it was just getting too old, but I don't have a new one. So I feel like I'm not doing all this because it's Apple. It's more about like everybody's just realizing, holy crap, this is awesome stuff. It's super fast and it lasts forever compared to the typical laptop we're all used to. So okay, so let's just assume that we're going to now have to compete on the Windows side, and all PCs are now going to have to offer an option for ARM. So if that's the case, now developers are like every developer team is now going to either have to insist that no one uses ARM or no one uses Intel and we're all in the same architecture, or they're going to have to support multi-architecture development. And then what happens when AWS ships more competitive chipsets, because they've got some on the horizon, and those are better performance per watt, priced better, because I feel like their first release wasn't that great. It wasn't a clear winner for all workloads to shift to ARM in the cloud, because when you start looking at the performance per dollar, it didn't always make sense. And in fact, in my case, I did the research on this like a year ago, and it was yeah maybe a year and a half ago, and it didn't really make sense for most typical workloads to actually switch to ARM for a price difference. Sure, the servers were cheaper, but they were slower. So if you wanted, if you were considering it dollar performance value, like you probably just stay on Intel. But that may change. Like they may do better processors and ship better processors faster than Intel can. So we're now all in a pickle because now we have to care about architecture. A year ago, most of us, very few of us, unless you were IoT or in some edge market where you were dealing with ARM, which I have never had one of my clients in 10 years worry about ARM, and now suddenly they're going to have to, I think. So, all right, back to the questions. That was enough rant. So yeah, I'm not an expert on ARM chipsets and all that stuff. So and like the players in that industry. So I'm not. There's probably better YouTube channels for that. I'm just looking about how this is all eventually going to roll out, and how if it's truly that great on the Apple ecosystem, developers are going to start. These are start going to creep. They're going to creep into the environment, right? 20 years ago, Macs were not a common developer platform, but as they got better and more, once OS 10 came out and we started getting Unix underpinnings, and developers started liking that experience, Mac started creeping into the developer teams that were previously all Windows, and they started creeping in, and then they had to figure out in the teams how to support developer environments on both platforms. And now I'm thinking, okay, now we're going to have to do the same for architecture, not just platform. David M says, admittedly, it's super slow in real life use. I'm able to crash Safari and the entire OS pretty easily. Yeah, and I don't think that's, the 6 months from now, I don't think that we're going to be talking about that kind of stuff. The first release of this is the worst release of this. So the M1 will be the worst Apple ARM laptop, probably, right? It's only going to get better. So if this is just the beginning and it's already outpacing other players in the market per dollar, per performance, per watt. Yeah. What's up, Jeff? Jeff changed his icon. So I'm getting all these great questions, people. Unfortunately, I'm focusing today on ARM and the multi-architecture stuff. So so many great questions, but we would be here for 3 hours if I answer all your questions. So I apologize. We'll have a more general Q&A in a future show, but right now we're sticking with Docker and multi-architecture. AWS's data centers will run on ARM architecture. Well, I don't know when you mean run on ARM architecture. There are already ARM instances in the data centers. Yes, you can buy those today. Yeah, KVM can run ARM too, like QEMU. I actually don't know. I mean, I don't know if someone else is answering that in chat. QEMU can run. It works with KVM, as far as I know, to help emulate an entire operating system on a different architecture. Yeah, the QEMU is the emulation layer. So we're going to get that into a minute. How do you think ARM will be available for desktops? I have no idea, actually. There's probably, I'm going to guess there's already an ARM desktop out there. It's probably just not popular, made by a major manufacturer. But if you want to say ARM desktop, well, that's the Mac Mini. Mac Mini is ARM, the new one, which is what I ordered and am waiting on. That's an ARM desktop. I don't know if you can run Windows RT on it. I don't know if anyone's got that working yet. So you can have Windows, but you can run Windows in Parallels, Windows ARM architecture on Parallels ARM architecture on a M1 Mac today. I've seen that working. I just haven't done it myself. Should you buy Mac to get to know Docker and ARM better? No. Okay, so this is a great question. You can run ARM images on Windows or non-ARM systems today. That's using something called QEMU. So we're getting enough questions about that. So I'm just going to talk about it briefly, and then we'll get into it a little bit deeper later. So just Apple computers don't run games. I would beg to differ because I run Blizzard games all the time. I was on World of Warcraft last night on my Mac, so it does run games, just not your games. Um, let's see. I run Docker, SOC, NVIDIA. When's there? Do you see any differences between where the M1 would go in tiny environments like this and the Pi? Well, the M1, it's like the M1 is just Apple's branded ARM, right? So really, I think your question is ARM. Well, ARM, the SoC NVIDIA GPU thingy is different. As far as I know, I'm not super. I don't. Is that an ARM? I thought that was all about GPU. I guess it's got to be ARM and plus GPU. I don't actually know anything about um, the NVIDIA hardware kits. All right. Yeah, I mean and Pickle Rick, this isn't about ARM. This isn't about Apple ecosystem. This is about choice, right? So, and I would say every developer team I have worked with in the last 5 years, so dozens of teams, um, they're all multi-architecture developers, meaning they have some developers on Windows, they have some developers that use Mac, they have some developers that use Linux as their OS, right? So in most shops, or at least in my experience, most shops, I'm sure that there's definitely companies out there that make a standard. They only buy Windows, they only support this and that. But Mac has crept in, and now Linux is creeping into these developer teams for many reasons. One of them is very much that if developer choice, developers have the power because there's very few of us to want to have choice. And if they care about the OS they want to be on, a team's kind of got to figure out a way to support them in order to keep them hired. So at least that's my experience. Like, developers have their own preferences, and now that we have all the right tools that work on all three of these different environments. So let's break this down a little bit real quick, because there's a lot of comments coming in, and I want to get to some of your answers. But so thank you for all this stuff. So there's two things to worry about here. We're talking about an operating system, so basically the kernel, and then the architecture. These are two different choices, right? They're two different many to many. It's a many to many relationship. So on the OS side, we have Windows, we have Linux, and then we even have mainframe. Okay. On the architecture side, we have half a dozen choices or more, right? We have ARM v7, 32-bit. We have ARM v8, the 64-bit that Apple's using now in ones. When you get chipsets in the cloud, they're 64-bit, I think, with AWS. I think that's again, I'm not the ARM expert, but I think that's like the v8 architecture. And then we have x86 64, which we all sort of call AMD 64, the 64-bit architecture that we're all used to, that I'm on right now. Servers in the cloud, 99% of them are probably that architecture. Instead of saying AMD 64, I'm going to say x86 64. That's the Docker nomenclature for it. That's one of the official ways to talk about it. So that's the Intel path, right? That's an architecture choice. And there are other ones. There is PowerPC, PPC. There's some mainframe stuff. There's 32-bit Intel. So there's x86 or 386 rather. That's a 32-bit Intel architecture. So these are processor architecture types, right? Motherboard architectures. And then there's the OS you put on them. So when you think about your Docker images, and you may not realize this, but each one of those images always has made those two choices. It makes an OS choice when you make that image, or when you're using that image. It's making a choice for you in the background based on certain criteria. And that's one of the nice things about Docker. It's also one of the things about Docker that you can get really confused about, because it's hidden away a little bit behind this manifest command and these manifest files, which we'll talk about. So on your machine right now, if you did a Docker run Nginx, a choice is being made on which architecture and which OS it's running on. Now, if you're on a Windows machine, there's actually this way in Windows where you can do the same thing, where you can choose between Windows containers, which run a nginx.exe essentially, or the default Linux architecture that we all typically use, which is a Linux binary. So that's the kernel compatibility, and then there's the architecture. For most of us, we've all been using the Linux kernel OS choice, right? A few of us are still doing .NET framework, which is fine. .NET framework, which is a Windows container. It's using a .exe binary that's compatible against the Windows kernel only, and you can't run that anywhere other than on a Windows machine. When Microsoft does not make, you know, an exe compatible Windows kernel that somehow runs on Linux or something else, right? You have to create a virtual machine, install Windows on it, and that's the proprietary Windows path. When it comes to architecture, what we're now talking about is that all of us have been, so you get an AMD system, sorry, not AMD, you get an ARM system. Until you get an ARM system, an M1 system or some Raspberry Pi or something like that, your defaults in Docker are going to be x86 64, and assuming you didn't enable Windows containers, it's going to default to Linux. And you can see that on any image. So if I just go to, I'm just going to pick an image, the node image. So in this image, you see these tags up at the top, and they're not all specific to architecture and operating system, but you can see in here that like this node image, it has a Linux, which I just happen to know that's an OS tag. So it's saying this is a Linux image, and it supports various architectures. In this case, these tags that it has on it. This is the 64-bit, what we're all using today. This is the x86 64 that is the default for most of us. It just, when you run an image, it's looking at your platform that you're running on. What is the operating system Docker's running? What is the architecture of that OS that Docker's running? And it's going to choose that image. You can change that with a -- platform option, and I'll show you some demos in a minute. But a lot of the Docker commands now have a -- platform option that lets you choose which one you basically, rather than letting it magically find the default that's for your local machine or wherever you're running the command, you can force it to use something else. When you do that, it's going to use an emulator called QEMU, which is not a Docker-specific thing. It is a generic thing that is for Linux, and it allows you to emulate VMs and applications from one architecture to another. All right, so this is specifically about emulating architectures on other architectures. And one of the big questions I had 8 months ago was, does QEMU support running x86 64 apps on an ARM 64 architecture? And it does, actually. Turns out it does. The opposite is true. It will run ARM 64 on the Intel x86 64. It goes back and forwards. So obviously there's a performance hit. All right, this is not something that you would ideally use in production if you can prevent it, because you're going to eat up a performance hit there. I've heard all sorts of numbers, but I haven't done my own testing. I'm looking forward to doing my own testing when I get my machine and comparing, like, on a Docker, one of the things I'm going to do is, once I get the M1, is on Docker, run the same performance test inside a Docker image on Docker desktop on both an Intel Mac and an M1 Mac, and do it both ways. So when you enable this platform option and you choose a different platform, it will automatically in the background, Docker desktop will use QEMU to run that so that it emulates that processor architecture. And so that's going to get a performance hit. So this isn't about comparing an M1 Mac to a regular Mac or an ARM, because there's obviously going to be performance differences in all sorts of nuanced ways. But what I'm curious about is, as a developer, if you have to be on one architecture for your machine, and then you have to develop or run Docker images of a different architecture, what does that look like? How big of a performance hit is that? How hard is that to manage? And what is it going to look like when we have teams of developers that are some are on ARM, some are on Intel, and now we've got ARM Mac, Intel Mac, ARM Linux, Intel Linux, ARM Windows, Intel Windows, like this crazy world that we live in, right? So how much of a headache is this going to be? Because this is probably my future as a consultant, to work with teams on figuring this out, learning what's called a multi-architecture Docker repository or a manifest file. Like, what is that? We'll get to that in a bit. So over here, back on the node thing, right? We go to tags, Most of us haven't had to ever care about this. So if I look at this OS architecture, this top one, this is the latest node image, and specifically for 12 Buster Slim. So Buster is a Debian-based Linux distribution, and so for that particular Linux distribution, they are pushing these different architectures of the same image. So in theory, they're taking the same git commit of node code, and they're building the image on different architectures. You can actually do that all at the same time nowadays with the Docker build X command, a new version of the build command that allows you to do a one-shot line that allows you to specify multiple architectures, and it will build that image in the background using QEMU. Or it can actually use remote machines that are on that actual hardware if you don't want to use QEMU emulation. So this AMD 64 is the one that we all have been using on our regular Intel machines. It just works. But it turns out if you specify any of these others, maybe not all of them, but some of them, specifically the ARMs, which is the topic of today. Oh, shoot. I'm not showing. Sorry. The AMD is this one over here on tags. And AMD 64 is a default. I can choose ARM v7. That's the 32-bit older ARM architecture. That's in older Raspberry Pis, some IoT things. And then there's the ARM 64 v8. That's the current one. That's what the M1 is running. That's I think that's what AWS's servers are running. Someone correct me in the chat if I'm wrong. Pretty sure those are 64-bit chips in AWS. And then there's other ones. There's PowerPC. There's 390X, which I think that's mainframe. I'm not actually sure on that one. I'm not sure what 390X is. Somebody help me out there in the chat. There are several IBM's, like IBM Z architecture. Yes, that looks like that. That's the S390X. That is the IBM Z mainframe architecture. Now, what's interesting, you may not realize, is that every tag that you have of an image, every tag has its own manifest file, which is this JSON file that's always been there. And it just describes, for a single tag, it will describe the layers of your image. Because when you say Docker run node, there's actually not just one file to download, So when I'm over on my laptop and I do Docker pull node, I'm just going to do, node 10, because I know I don't have that one. So in the background, Docker's going and asking the registry, Docker Hub, for the manifest because it needs to know which layers to pull, because each layer is its own file, and each one of them has their own SHA hash that it has to find, the digest, in order to find that stuff. It also is doing this thing around architecture and operating system that we've never really, most of us, ever cared about. So Docker has a relatively new command called Docker manifest that I can inspect or see the manifest file of a particular image. You can also use Docker manifest to create your own for your own images. Now, in the background, this has actually always been happening. When you create a Docker image with Docker build, it's creating that manifest for you just for that image, whatever system that you're on, that you're building on, it would just default to the architecture and the OS that you're on. It assumes that's what you want to do unless you override the defaults. And it would make that file, that JSON file, exist. And then when you push that image, it's pushing that manifest with it to the registry. It has to be there. So it's always going to specify the architecture and the OS. But now we may have to care about this more, and you may have to start building your images for your team with multi-architecture support so that your developers that are on an M1 or the future of Windows RT, I think is what it's still called, you're going to have to build your images so that all developers can run them on these different architectures so that they're not forced to only use Intel, which is what we all have today, right? So if I do Docker manifest inspect node latest, I want to be specific here and show a tag because these manifests are specific per tag. JQ. I'm using JQ here. This just makes a pretty print of JSON. So it'll put it out in a prettier format. And so this is a pretty small one, actually. There's only 3 of them for this particular image that it's showing me. And it's showing me Linux AMD 64, Linux ARM v7. So notice that there's this architecture and variant option. We'll get to that in a minute. and then Linux ARM 64 v8. So on my system, because I'm running an Intel Mac with Docker Desktop, when I type docker run node, it's on an AMD, let me get it right. It's on this one, AMD 64 Linux, because in the background, Docker Desktop is running a Linux VM through the hypervisor of Apple. And this is the same thing on Windows, right? If you're using WSL2 on an Intel machine, it's going to be running a Linux AMD 64 VM. And so it's going to choose that same architecture and OS when you type docker run. Now, when I do a docker image ls for you, you will see all these images right here. It turns out that several of these images are not the AMD, x86-64 Linux architecture. A couple of these are different, and I would have to inspect them. That's why you see these tags latest, because I actually pulled these down. Oops. I pulled these down specifically because they're different architectures. So I can specify the first couple characters of an image ID and docker inspect FC0, for example. So that's this third image on the list. Notice that it has a tag of none because I actually pulled a specific image there, not by tag. So when I scroll up on the inspect of that image, I see here that it's ARM architecture. So I am storing the image of an ARM app inside the VM on my local Mac. So this is in a Linux VM that's running x86-64, but it's storing the app built for ARM 64 in that image. And I can run that same thing. So I can do a docker run. Let's do our docker image ls again. Docker run. Now, a couple of things I can do here. Normally, I can do a platform. Okay, you kind of see my command line kind of pre-filling in some of the things I was testing. But I can do a platform and Linux / AMD 64. This is what kicks in the QEMU. So now Docker is going to have to emulate this. I'm sorry, not ARM. I want ARM there. ARM 64, not AMD. It's going to emulate that ARM machine through QEMU and inside that machine. So this is the thing you can do right now. So you can run these ARM images. You can find out if the apps you use have ARM compatible images, right? So you can know whether or not your M1 will work. You can go search them on Docker Run or Docker Hub, or you can just try running them here. Now, if the platform doesn't exist, you'll get an error that doesn't exist in the manifest, that image doesn't exist. And that's your way. It's its way of telling you essentially that someone has not built that application with multi-architecture support and put it on Docker Hub. All right. A lot of the official images are cross-architecture, but not all of them, and certainly not a lot of the industry stuff, and especially probably in your company. If you've never had to worry about it, there are no ARM 64 images of your apps in Docker Hub. It's only going to be the x86-64 stuff that you're probably building by default. All right. So if I just do node, well, that's a bad example because it's just going to run and quit. But if I did ARM and did this, so it's going to go and pull down the ARM image for Ubuntu and then give me a command line in there, right? Now, I'm just going to quit that real quick. But if I look at that container, so if we do a docker inspect of, let's see, 279 was the first part of the image. That's the container name, not the image name. So if I scroll all the way up here, oh, it's huge. I'm just going to search. You can see that that container is indeed running ARM. It's running an image built for ARM on my Intel Mac. So what does this mean for Docker Desktop on M1? This means that the Docker team actually chose that if you're going to be on an M1, which is unfortunately we don't have a Windows ARM Docker Desktop yet, but I got a feeling that that's they're maybe not necessarily planning it, but that's something that's going to happen once the community demands it, because they got a huge outcry for M1 support for Docker Desktop, right? And of course, Apple actually said it in the keynote, so it kind of had to happen. Um, but on the Windows side, as ARM becomes more popular there for developers, because it does exist today, but I don't believe there's a Docker Desktop for that. So Docker will have to build that support once the community, you know, goes in. You have to go into the roadmap on GitHub and then thumbs up that you want Windows ARM support. And the more people that do that, the more likely Docker will do that, because that's kind of how they're choosing some of their decisions for what they build next. So on your M1, when you type docker run node, it's now going to default is what I meant to say. It's going to default to that ARM 64 V8 architecture, which means that if you just pick up a Mac and you start running your apps, unless those app images have already been built, you're going to have a problem. Like if you're pulling, let's just look at something that's pretty common, right? Postgres probably works. I'm just going to assume Postgres has an ARM image, but I'm pretty sure MySQL would work. So let's just go see. So check this out. Yeah, I only see x86 there. So it looks like the default MySQL image only is built for AMD. Again, forgetting my screen. So I'm looking at the ARM. I'm looking at the MySQL image, and AMD is the only one that's supported. So if your Docker Compose file has a MySQL in it, and you just grab an M1 and do a Docker Compose up, it's going to fail, because it can't find the image for your architecture. Now, you can still use this image. You just have to specify the platform. And that's just something you would need to sort of hard code into your stuff. So let's go look at Docker Compose. Yeah. No, I want the spec. Show me the spec. List of features. Okay. There we go. No, that's not what I wanted either. Okay, there we go. I didn't actually know if this existed, but I'm not sure I'm seeing it. So what I'm looking for is how to hard code the platform in Docker Compose. This may actually be a problem for us. So we know you can do -- platform from the Docker run command line. What I assumed was that Docker Compose would allow me to also specify that in the compose file for which platform it's going to run. That may not be a thing. So I'm just going to put this one. This is actually a pretty good one. This talks about the multi-architecture stuff. So I'm going to put that in chat. It's a good link there. But yeah, BuildX is the way that you build these images. We talked about that earlier. And it talks a little bit about QEMU and how that's set up. So real quick on the QEMU, it's built in the Docker Desktop. It's a convenience feature that Docker Desktop provides you. On any Linux system, though, like on a Linux server, if you wanted to also do this, you could just install and enable QEMU yourself and basically tell Docker that it's available. Once you've done that, and I believe Docker has documentation on it, once you've done that, then Docker will do this same thing that you can do locally on any Docker Desktop machine today. It'll do this same kind of thing on a Linux machine on a server. So you just have to set that up yourself, because it doesn't come out of the box with a Docker engine install on a Linux machine. All right. Ooh, Paul says, look at the version 2. Would that be another thing that's not that's not specified? Oh, look at that. Thank you. Thanks, Paul. Um, so yeah, so version 2. Now, this one thing that I should test is as of this is a side note, Docker Compose as of the latest version 1.27, the Docker Compose command line no longer requires a version field in your file, and essentially, it supports now. My understanding is it supports all the version 2 and version 3 stuff all in a single file. All you have to do is just remove the version line from the top as long as you're running Docker Compose CLI version 127 or newer, which is months, if not, it's maybe 6 months old. So anyway, we're getting rid of the version in Compose spec, which is great. So yeah, so you can hard code this, right? So you can do this in your Docker Compose files, and then on your M1, it will download and run the things that it has to that you don't have support for, like MySQL. It'll run those through QEMU and emulation. Now, I haven't tested this myself, but the Docker team has told me that the performance is actually pretty good because the M1 chip is so much faster than what most people would have in their laptop today. Um, I've got Apple's most expensive 16-inch brand new laptop that is now not as fast in some cases as the M1. So I'm expecting, like, if I were to buy an M1 laptop, MacBook Pro today, that's a fraction of the price of the one I bought, that because of the performance improvement of the M1, that the emulation you may not notice it, is my point. You may not notice that the QEMU is technically slowing things down because you're getting a faster chipset. So I have yet to test it, and I don't have any performance specs of my own, and I haven't seen anything coming out of the Docker team, so I can't promise any of that. That's just what I expect. Sorry, I'm really behind on chat. Jeff's asking, is portability or multi-architecture support that people are actually concerned about between the vast adoption of interpreted languages and language native cross-platform? I thought this was over. Yeah, I don't think it's over, Jeff, because I work with a lot of companies that are just now adopting Docker, and these companies have never even had to think about multi-architecture. My concern immediately is about developers choosing M1s, and that Windows ARM, I think, is now inevitable unless some Intel or AMD can pull a chip out of their hat that's somehow going to solve this problem. We're going to end up in a world where laptop manufacturers are looking at how they can make Windows ARM better, and Microsoft's now going to try to make Windows ARM better instead of a side project, and more apps will be, the demand is going to create more demand, and the competitive advantage of Apple is going to create more demand on the Windows side for ARM, and that's my theory anyway. Like, this is obviously not going to happen overnight. This is going to take years, but I'm looking forward 3 years, 5 years, and I'm kind of thinking this is going to end up being a world where we're going to have people on Windows and Macs, both sides, on both architectures, having to develop on the same apps. And how do they do that? Most of us, in fact, none of my clients have ever had to that I can recall, ever had to create a manifest file to do their Docker work or to deploy their apps. Because the silicon in AWS for ARM isn't so amazingly faster per dollar, I don't see yet anyone that I've worked with choosing that platform on servers on the internet simply for cost savings, but that's a potential, right? We could see that in the future if ARM indeed, if the silicon that AWS is making gets that much better and it becomes that much cheaper, we could see that as well. So now you're going to have, there was a time, maybe a year and a half ago, where I was telling people and making videos saying, hey, if you want to use these new servers running ARM on AWS's platform that are really cheap, they're kind of slow, but they're really cheap. If you want to use those, this is how you do that on your Intel machine with Docker Desktop, right? I was talking about the manifest file and how you would build it and using the platform option and all that stuff. So But that may not actually be what's going to happen. Like it may be driven by the fact that Apple has now just decided eventually everything's going to be an ARM architecture. Like we'll maybe still sell Intel for a while, meaning years, but I think that's their announcement, right? Is that eventually 3 years from now, they haven't really given us a timeline, I don't think, but I thought I heard 2 years at some point, but I'm not sure if that's changed. Yeah, Surface Pro X is ARM. Yeah, and I had one of those. I had the original Surface ARM machine, and it was This was, of course, almost a decade ago, but this was crippled. It was crippled because nobody was building their apps, right? Nobody was cross-compiling their apps, so you couldn't run all the apps on the internet, even though Windows itself ran and the browser ran. That was about it. Like all my developer apps, all the add-ons, like those are all just built for Intel. So we've got to get more people on Windows ARM so that the demand is there for the developers to care about cross-compiling their apps. So I'm not. So I'm thinking about it more from a perspective of the developer team now having to deal with multi-architecture. David's saying if you're buying an M1 Mac, make sure if you're getting the 16 gig of RAM. Yeah, it's a nightmare without it, even if you just do moderate web browsing. Yeah, most people that I've heard that I've seen a lot of YouTube videos, and all the people that are saying they got the 8 gig one are returning it for a 16 gig one. I run a small IT company right now. Should we switch to Mac because many companies do the same? That's a totally different conversation, but it's to me to me giving people choice. If you're concerned about retaining talent, give them choice. That's the developer teams and the teams that I work with. If they mandate a developer do all the different things their way, they're going to have a hard time of getting the best talent, I think. So giving people choice is kind of what most companies are being forced to do with their developer and software teams. Kubernetes losing support for Docker was a previous episode. Just search my channel, Bret.live. We talked all about that a couple of months ago. Just look for Kubernetes or Docker Shim. There was a whole episode dedicated to Docker Shim. I'm actually walking over to Best Buy right now to pick up my M1 Mac Mini. I have lots of plans to test it. Yeah, cool. Yeah, 2 years to complete the transition. I'm seeing that the RAM thing is FUD. All right, so I'm catching up on chat. Sorry. I had some issues running some tools like Ansible Terraform inside Docker container on M1. I'd be curious what your issues are. Obviously, we're in preview right now, but hopefully you're reporting those issues to Docker because we're still in early days, right? The preview releases we're using have only been around for months, so this is pretty early days for Docker. So expect rough edges, but interested in what your problems are. You're using the upcoming feature from Docker called BuildX. Well, BuildX has been around for years, so it's not new. So it should be perfectly fine. It should work great for you. That's how we can do it. Yeah, and M1 Macs don't support multi-monitor. So from a software development point of view, when will they really care about the underlying architecture of the infrastructure apps are deployed on? Well, in a multi-architect, because we've all been on Intel and we haven't had choice, no one had to care because everyone was just building on Intel and shipping to Intel. Your servers were Intel, your laptops were Intel. But what happens when all your laptops are AMD and your servers are Intel? Now you have to build for a different architecture than what your machine's on. Or what happens when all of your build machines are still Intel, but they're building images that you're going to run on your local machine, but your local machine isn't Intel anymore. So you're going to have to care about that manifest file, and you're going to have to start learning the buildx command and how to build multi-architecture images. There we go. Yeah, I knew somebody would know about the mainframe. Yep, a couple of you got the mainframe thing. I'm going to skip past some of this. Sorry if I missed your questions. I'm trying to look for questions. The pre-filled commands on my CLI, that is ZSH. So look up ZSH, specifically oh my ZSH. If you go to bretfisher.com/shell, that sends you to all of my stuff. bretfisher.com/shell. So that whenever I show my shell stuff, I should just have that link on the screen. So that's going to give you all of the specifics about the themes I use, the add-ons I use, stuff like that. But that is specifically oh my ZSH. If I switch to Windows containers and Docker Desktop for Windows, it will run the images in them instead of WSL? Correct. Correct. Yeah, when you switch to Windows containers, there is technically, I think, I don't know if it was a beta feature, I don't know if it still exists anymore. There was a feature that allowed you, it would actually in the background, you could create a Linux VM and a Windows VM at the same time. Don't know if that was like years ago. I don't know if with WSL2 how that's going to work or if that even is supported. So I assume right now if you enable Windows containers mode, there's real no way for it to spin up the Linux VM anymore. I could be wrong on that. Someone help me out in chat if you know for sure. If I migrate a Docker container from AWS Arm architecture to my private K8s environment, which is x86, will hit performance impact due to QEMU. What are the suggestions and best practices to avoid performance hit? Well, then, I mean, you're either using QEMU or you're not. So I don't know how much QEMU tuning there is. On a server, I would never recommend you do that. Maybe on build servers, if you don't want to run multiple servers for different architectures. Maybe your build servers use it for building. But for production kind of stuff on a server, you're always going to want to build your image for the server architecture that you're on. And you would use the docker buildx command to do that. So Evan is asking, yeah, just to emulate, just to reiterate, because the MySQL image doesn't have the build on Docker Hub, you'll have to emulate it on the machine in order to build the image. Yes and no. I think what you mean is in order to run the image. So in order to run MySQL on an M1 Mac today, it will have to use QEMU emulation. And you'll have to specify the platform. So you would have to do docker run -- platform Linux ARM64 MySQL. That's how you would make it work. And then it would automatically kick in the QEMU. Ooh, Biker's asking, what I'd like to know is how do I build multi-arc images? Or does the repository have separate images and somehow sends you the right one? Yes, that's exactly what's happening. So in a registry for the repository, right? So let's say the node repository, since we're talking about node. In that node repository, for each tag, you can technically push an image for various architectures, and they will all run under that same tag based on the architecture of where you're running it. Because Docker will always default to matching the image architecture to your architecture that you're running on. The -- platform option is to override that default and run a different architecture, assuming you have QEMU enabled on your machine. That's how that works. So when you do a Docker push, you're pushing one of those, unless now I think you can do Docker push. I don't know if it's all or there's an option in there. I can get to that in a minute once I catch up on questions. That allows you to push, I think, all of the different architectures at the same time. I could be wrong on that. but you essentially would use a buildx command with the option of which platforms you want it to build for, and then it would build multiple ones, or just one if you wanted to build a different one. When you do a Docker buildx by default, it builds to the architecture of the machine you're building on. That's the sort of Docker approach, right? Everything's default out of the box to the assumption of the majority of people, what you really want, and then you can override those defaults. That's why it works that way. Won't CI/CD tools willing to take care of most all the hassles around having a multi-architecture development team? I don't think so, because, well, one, the CI person has to now build those images for multi-architectures. But again, it's all about running these on your local machine. Someone's either going to have to update your Docker file. This isn't, by the way, this isn't a Docker file thing, actually. This isn't, you don't specify the architecture in the Docker file. You specify it when you build that image. Now, it's possible you can have one image, you can have one Docker file that would work, possibly, on multiple architectures that you build. You would build the images for each architecture, and it's possible that Docker file, depending on what's in it, would work for each one of those. And that's largely based on, is the image if you do a from image, does that image also support the same architectures that you want to build for? Because it's going to have to match, all of the different layers are all going to have to match that same architecture. So you can't cross architecture, the layers of an image. They all have to match. So if I do a Docker build node on a Raspberry Pi, it's going to pull the ARM, the ARM64 version of node. It's going to pull that from image and then add my code in on top of it, and then do any npm commands and all that. If I did that same Docker file on an Intel Mac versus the Raspberry Pi, it would actually build a different image by default. It would build an x86 64 image. And most people just haven't really noticed that, because until they do, right? And when they do, it's because they try to run something on a different architecture, and Docker keeps saying, there's no image for that in the manifest. There's no image for this architecture, or whatever the command is. In fact, that's what would happen here if I do a Docker run platform ARM, and we know MySQL doesn't work, right? Because there is no image for it. So it gives me this error: no matching manifest for that architecture in the manifest list entries. And we know that because we went and looked at MySQL on the website. But I could also do a Docker manifest inspect MySQL latest, and it shows me one architecture, but only has one built in the registry. If it showed me a list of 2 or 3, then I could use the -- platform command when I do a pull or when I do a run to specify or override the default. Hopefully that's starting to sink in there. All right, let's see. Thanks for the 2 years suggestion. So just so I understand, if the image on Docker Hub doesn't have an ARM available, Docker Desktop will have to emulate. Yes. Yes. That is correct. You're asking about omyzsh give Docker command line completion if implemented on Windows in PowerShell. So you can't run PowerShell and omyzsh at the same time, right? ZSH is a shell, PowerShell is a shell. They're different. They would use different things. So if you're running omyzsh, that's just a distribution of the ZSH shell with a bunch of nice stuff on top. And so that you would have to also make sure that autocomplete is installed, which is another thing for the shell. And I'm not sure if omyzsh does install that by default. I haven't tested that on Windows, whether it installs that by default. And then you would have to download the Docker stuff, which some of that does come out of the box with omyzsh, but I don't know about how easy it is. But yeah, it's either that or PowerShell. Can't do both. Just so I understand, if the image pulled from Docker Hub doesn't have a build that is native to my machine, its only choice is to emulate what is available on Docker Hub, correct? Yes, but it's not going to make that choice for you automatically. See, the command I just ran, it just errors out. So it's not going to try to emulate things. It's not like it's going to fall back to emulation, right? You would have to specify that um, as a platform alternative for Docker to do that. It's not like Docker's going to try this image, and then if that architecture doesn't work, then it's going to try this one. That's not a feature yet. At least I don't expect it to ever be. I haven't heard anyone doing that. Oracle lectures? I know nothing about Oracle. I'm assuming you're talking about Oracle databases. There's a lot of things that Oracle makes, but I don't know anything about Oracle databases. Sorry. The push flag generates a multi-architecture manifest and pushes all the images to Docker Hub. Right. Okay, great. Thanks, Paul. So on Docker build X, help. All right, so, and specifically, I want to do a Docker build X build help. We can kind of explore. So when you do a push, this is like a one-liner that you can basically do now where you do Docker build X build and you specify the platforms, right? So there's a lot of stuff we can do here in the builder. And if we specify the platforms we want to build for with the -- platform, and then we specify the push, it will actually build these images and then push them all. And I tested that when it first came out, but I haven't done it since because I've not been working with teams that need multi-architecture, and most of the time, quite honestly, I haven't been using the build X command in most cases because teams they're just now getting there with the Docker build command. Like build X is still pretty advanced for relatively new shops to Docker and Kubernetes. All right, so I've all caught up on that. So let's look at some other stuff. What other questions do you have? What have I not answered? I have to look up a Docker file that I can build here real quick. I need to look up a node example. So instead of doing an example, because we're already running long on the show, what I'm going to do is I'm going to give you the docs, because the docs already have examples. And we'll just, we'll go through the docs real quick. And I also don't want to wait for the build to finish, but I could do a sample one. So here we go. Working with buildx. So the buildx command, I still think it's an experimental. It's marked as experimental. That doesn't mean you can't use it. It just means that the features of it may change. Once it's out of experimental, it's kind of Docker's basically saying they're going to support all those features for as long as they can. But when it's in experimental, like the command line options might change. They might add one or remove one, or the way it works might slightly change. Doesn't mean that it's necessarily entirely unstable and that you should never use it. People have been using buildx for real world stuff for years now. It came out in like the 1903 release in 2019, so it's definitely been out there. But all right, so what do we got here? So for multi-platform images, we can see this right here. Here's an example. So just like I use the platform to run it, I use that -- platform to build it. And I can specify one. If I don't specify anything, it's again going to build on the platform that I'm on. It's going to build that image. Linux, AMD 64 for most of us. But I could specify ARM as a second one. It would then build both. And if I specify -- push, like Paul reminded us, it's going to then push both those images based on the tags that I specify here in the command line. It's going to push those up to your registry all in one go. All right. Let's see if there's any more chat about that. I don't know if that's a good enough example for you, Biker. you have any approach running QEMU to run Linux with Docker API on Mac and access with Docker client outside that VM, just like Docker Toolbox did? Ronald, I'm not sure about this question. With Docker API on Mac M1 and access with Docker client outside that VM, just like Docker Toolbox did. Okay, so I guess you're talking about how do I run a not Docker desktop, just Docker in a VM, and then how do you do QEMU in that VM, and then do the Docker command line from your host? I think that's what you're saying. So like Toolbox used to do. I don't have basically the steps, and I don't have this written down. I don't have a blog post on this. The steps are, create that VM, install Docker. Then you need to install QEMU and enable that in Docker so that it knows where to find it. Docker has documentation on that. So if I just search their docs for, I'm pretty sure this is, I'm just going to search it. Docs. Okay, maybe it's not in the docs. Yeah, that's not going to be there. So Docker, QEMU, Linux. So I haven't looked at this one. This is from Stereo Labs. So here's showing the QEMU doing emulation. So this is doing, this is not specifically AMD, ARM, but it's kind of showing here how QEMU sort of puts itself in the middle, right, as the emulator between your applications of one architecture and the kernel of a different architecture. That's a pretty good one to have. And then if you just look up QEMU install, you basically need to install that. And Docker will use that based on, I can't remember if it's a config in the Docker config file, which is in /etc/docker/config, I think. Maybe config.json, not sure the exact name on that. But for advanced details on using QEMU in Docker, please refer to this repository. So yeah, I looked up how to do this a year and a half ago, and I haven't done it since. So if someone finds a really good walkthrough of basically how to do this on a Linux machine, right? Now, then once you've done that's the next step. Now, install the Docker command line on your Mac. So maybe you just used, don't install Docker Desktop. I mean, you could, but if you don't want Docker Desktop at all, if that's your purpose to avoid Docker Desktop, then you would just need the Docker command line that's built for Mac, and you can probably get that from Brew. And then you're going to use the Docker context command to use probably SSH to talk to that VM, right? So you can use an SSH : // that's one way to tell Docker to talk to another system is through the SSH, and if you set up SSH in your VM. So that's how I would do it, right? If I wanted to have Docker on my local machine and a local VM, and that VM, running QEMU in that, so I could do other architectures. You could just run a different architecture VM. I don't know if that even works. I know QEMU can do that, but I don't know actually how to do that on Mac. I've never actually tried to do that. Like how could I create an ARM VM on an Intel Mac? I don't even know. I'm assuming that's possible because I know that suppose the QEMU can do it, but I don't know how you do that. I've never tried. All right. Was just wondering if using this approach could be possible running, AMD 64 images. I think so. Hey, if can I assign you homework? Take this home, try it. Once you get your M1, try it. And tell us what roadblocks you hit. Like, what's the problems? and maybe we can figure it out. Anyway, all right, so I'm going to wrap this show up, but stay tuned because what I'm going to do is I'm going to have other people on this show that are smarter than me about all this. Hopefully, maybe some Docker people, maybe someone else from the community. In case you're wanting to get started in this stuff, I'm going to do basically, this is one of many ARM plus Intel focused shows that I want to do. And so this one, again, I just thought it up this morning. I had no content planned, no examples planned. But hopefully throughout this year, as we get the full release of Docker Desktop for the M1, and I can only imagine it's a matter of time before we hear more announcements about how the Windows world is going to compete with this new, new and better laptops that Apple's shipping. That now everyone else is going to have to scramble to say, hey, they've got 18 hours of battery life too now. Like, I don't know if that's going to take years to do. Like, are we literally going to have years of Apple killing it with ARMs and, the other manufacturers just can't compete anymore? Or I don't know what's going to happen. But it's going to be an interesting, fun time. And for those of you that are going to be able to have a Raspberry Pi or want to get into this multi-architecture stuff with M1 and stuff, I look forward to having a future show with you. So come back here every Thursday. I'm live. You can support me on Patreon. Thank you so much to those of you who are on Patreon and a part of my Patreon support. You can just follow me there to get all my updates whenever new things released. We're working on new videos for my courses all this month and probably next month. So expect to see more updates for that. And if you want to buy me a coffee, I really appreciate it. We now have over 100 people supporting me that way, and it really keeps this show going, as well as the podcast, which we are currently editing the next episodes to drop on the podcast. You can get all that stuff at patreon.com/Bret Fisher. I thank you so much, and I will see you all next week. And I don't know the topic for next week, so stay tuned. It might be a short show because I'm actually going to be out of the office. I'm going to be traveling next week, so I'm not sure. Just watch YouTube, watch my Patreon. I will be putting that stuff on there, as well as my social. So thanks again. See you soon.